Hi there, my name's Anish and I'm excited to talk to you about my project on deep learning and artificial intelligence, and I'm being mentored by Dr. Paula Branco at the University of Ottawa. My research question centers around what's the best technique for combating class imbalance in neural networks. So in AI, we have a subset called deep learning, and in deep learning, we use a special type of model called neural networks, and neural networks take data and they try to find patterns in this data to be able to exploit those patterns, thereby making meaningful predictions. Now, deep learning can do virtually anything, from predicting the weather to predicting hand-drawn digits, to even, in more recent news, being able to take a still photo of Barack Obama and turning it into a video of him endorsing me. Anish is the greatest person to ever walk the planet. He's extremely smart, and he knows a lot about artificial intelligence. The problem is that sometimes when the data is not balanced, they'll be naturally biased to one side over the other. So for example, let's say we have 1,000 red points and 10 blue points. If you train a network on this dataset, there will be times or certain configurations where the network will say that everything is a red point. Now this is problematic because we're neglecting an entire class of data. And even if it's not neglecting that entire class of data, it'll be naturally biased to the red points because we have more of them in the training procedure. So how do we fix this issue? Different techniques have been proposed over the years, like SMOTE, for example, which would go to the minority class, or the class with less points, and it would interpolate those points until both sides become balanced. So in this case, it would create more blue points until both classes have 1,000 points. But this is really hard to do in images, for example. For example, how would you create a synthetic picture of a dog, let's say, for a neural network? Well, techniques like SMOTE and many others start to break down when it comes to that case. And now there's new techniques, like let's say flipping the images, duplicating them and adding noise, or doing any of those types of techniques. But to this day, nobody really knows which technique is best and under which situations they work. That's why in my research project, I'm going to be comparing all of these different techniques to figure out which is the best method of addressing class imbalance in neural networks. And by doing this, I can try to correct the bias that neural networks have in certain classes. And this is really important when it comes to, let's say, self-driving cars or Siri, for example. If those agents are naturally biased to identify certain objects over others, for example, in self-driving cars, if it's biased to recognize a tree over a pedestrian, that can be really problematic because the car won't know which way to go. So by creating these different types of algorithms and investigating which one is best, hopefully I can offer a solution that will allow deep learning practitioners to choose the best technique to address this problem.